Hello, my name is Clemens. I'm the CTO of Persival, and today I'm going to give an introduction into the topic of co-simulation. You're probably familiar with all-in-one simulation tools that have traffic simulation, vehicle dynamic simulation, maybe some sensor simulation. But a lot of times you need more specialized models, and you want those models to come from the people, the departments, or the companies who know best about the component that is modeled. So you want your vehicle dynamics simulation to come from the vehicle dynamics department. You want your sensor simulation to come from the actual supplier of the real world sensor, because they know best what their sensor can and cannot do and how to model that. And that's where co-simulation comes into play, because co-simulation means you can plug models from different sources together in one simulation. Let me show you what an example of a co-simulation architecture can look like. Of course, first you need to define what is to be simulated. So you have some form of a scenario, you have a scene, maybe a map to drive on, and if you need rendering or more advanced sensor models, you also need 3D assets or 3D environment to simulate it. And then you have your models. First one typically is a scenario player. So you read in your scenario and the scenario player plays it back during the simulation runtime. The output of that you can feed in a sensor model or multiple sensor models, and the output of them you feed into your perception stack. It can be a sensor fusion, can be object detection algorithms or tracking. And then it goes on in the automated driving architecture. You have your behavior planning, you have your actuator control, and you can actually feed that via vehicle dynamics simulation back into the scenario player for a closed loop simulation. Or you can have any combination of these models. Maybe you're just interested in the sensor output, so you just have a scenario player and a sensor model. So it's a very flexible way of setting up your simulation. And it has another major benefit, because you have individual and individually packaged models. They can be validated individually. For simulation, it's always the question, is it a credible simulation? Can I trust my simulation outcome? And for that, the simulation and each model need to be validated. And the major benefit here is because those are self-contained units, you can validate them individually, and then you have, for example, a valid sensor model, and you can, once you've validated that once, you can reuse it in different simulation architectures. And that's a major benefit of using co-simulation. But enough about the theory. Let's actually get to it and build up a co-simulation. For that, we first need a co-simulation master. So we need a software that orchestrates the co-simulation, where you define what models you have, how to plug them together, what the interfaces are between them, what the timing is. All that is done in a co-simulation tool. There are a lot of options out there, one of which is the AVL Scenario Simulator. This tool is free to use, so you can go to the AVL website or just Google AVL Scenario Simulator and download it, install it, and use it for free. So that's the first thing we need. That's kind of the frame around the co-simulation. Then, of course, we need our components, our models. As I said before, the first one is a scenario player. We are going to use esmini for that. Esmini is an open source, free to use scenario player, and that's available on GitHub. And we're going to use that. Well, for co-simulation, you need a certain packaging. As I said, they're self-contained units, they're packaged, and that's where the FMI standard comes in, the functional mockup interface. And the FMI standard defines how to package these models into what's called a functional mockup unit, an FMU. And lucky enough, esmini comes with an implementation of an FMU. So you can go ahead, go to the GitHub repository, follow the README, install esmini first. Then you can already use it as a standalone tool, but to use it in co-simulation, you can go into this folder, the OSMP FMU, and follow the instructions in the README here. And what you'll end up with is a .fmu file, and that's your packaged model. That's what you can use in a co-simulation. Next to the scenario player, we need another component. Today I'm going with a simple architecture. We just have the scenario player and a sensor model. And the sensor model we're going to use from the open source model and simulation library from ASCS, it's OpenMSL. And there are different ones available. We're going with the simple one. There's a sensor model template. And if you follow the README here, you can download it, you can install it, and you will also end up with a .fmu file. So now let's open up the scenario simulator. I've already opened this up in the background. That's what we have here. When you first open it, you have just greeted with a blank canvas. And that's actually what we want. We want to build up a co-simulation from the ground. So also already prepared the FMUs. So we have the esmini FMU and the sensor model template FMU. And what you can do now is just drag and drop them in here. Let's put both in here. And now you see the scenario simulator recognize that those are FMUs according to the FMI standard. And you also see some interfaces. We're going to use as an interface between them the ASAM OSI standard. I'm not going to go into detail into this interface in this video. I'll make a dedicated video just about this interface. But basically what you can do now is drag the output of esmini or scenario player to the input of the sensor model. And that's it. That's first version of a co-simulation. It's as simple as that. But we could already run this, but we wouldn't see anything because of course we need to store the simulation output. And the scenario simulator comes with a scenario recorder, and we can use that. First we need to define the inputs. We're going to record both the output of the sensor model, but also directly the output of esmini, which is just the ground truth. So esmini transmits ground truth object list, means where, at which time during the simulation, which object is at what position, at what orientation, and so on. And we are also going to record that. So we have it's called a sensor view, and then we have a sensor data output here. And you see two ports here, and we can connect sensor view to the recorder, and we can connect the output of the sensor model also to the recorder. Now we need to define one more thing before we can get started. We need to tell esmini what scenario to simulate. And there's a parameter for that. This XOC path. XOC is a data format for ASAM Open Scenario XML. That's a scenario definition standard. I will also make a dedicated video just about Open Scenario. But for now, we can just use an example scenario that's provided with esmini. And you just copy and paste the path in here. We're using a simple cut-in scenario. So a vehicle is going to overtake the eco vehicle and then cut in front of it. And here we have another parameter, use viewer. We also gonna set that to true, so we can actually during runtime see what's going on. Now you can switch to the live tab, and we can just run the scenario. So here we have this run button, and we're just going to click run, and actually drag that window here. You will see the scenario. So the red one's overtaking the white one. White one is our eco vehicle, and then it's going to cut in front of it. So a very simple scenario, just a couple of seconds of simulation, and that's it. That was our co-simulation. Looking at runs, you see here with this green square, we've had one run. And now we can actually replay this. So let's have a look here. Let me actually pause this for a second. So you see here our two vehicles. We have our ego vehicle here, and that's the object vehicle. On the left, you can see our two data streams because we recorded the sensor views, so the output from esmini, but we also recorded the sensor data output. And the ground truth from esmini is in blue, and the sensor data is in green. But wait a minute, there's nothing green here. That's actually because the sensor is configured as a front-facing sensor. It has a field of view only in the front of the ego vehicle. So at this point in the simulation, it can actually not see this model or this vehicle. That's why it's just ground truth, and the sensor does not output anything. But if we continue now, this will drive into the field of view, and you now see here in green we have the output of the sensor. It's an object list sensor model, so it outputs detected objects, and that's what you can see here in green. And you can also see a detection probability here. And that's our whole scenario. So we set up a co-simulation, we simulated a predefined scenario with a sensor model, and now we have the output. And it's as easy as that. If you have your components in the right format, you can just drag and drop them into a co-simulation master, connect them, and run your scenario. It's actually quite simple. In my next video, I'm going to go more into detail about the standards we used. So OpenScenario, where we define the scenario. Also OpenDrive comes into play, that defines the road layout, so where to drive. And we'll also be talking about ASM OSI as an interface between them. So stay tuned and go into the next tutorial to look for the next links. And if you have any questions about co-simulation, feel free to drop a comment below.